Morning students. In this class we'll solve some problems on the depression of freezing point. On this colligative property we are going to be solve some problems. Just observe the problem given on the sheet. A solution containing 18 gram of non-volatile non-electrolyte solute is dissolved in 200 gram of water. Freezes at 272.07 Kelvin. Calculate the molecular mass of the solute. Given the Kf, that is cryoscopic constant, they are given. Kf is equal to 1.86 Kelvin kg per mole. And freezing point of water is 273 Kelvin. We know that freezing point of water is 0 degree Celsius. When it is converted into Kelvin, we are going to get that 273 Kelvin. Here we need to calculate the molecular mass of the solute. What they are given, that we should write down the first. What they are given? They are given the mass of the solute. The mass of the solute we are going to be taken as the W2. W2 is equal to 18 gram. Then mass of the solvent they are given. That is the mass of the solvent is equal to W1. W1 how much they are given? 200 gram. And they are given that TF and TF naught. That is TF. How much they are given? That is 272.07 Kelvin they are given. Then TF naught they are given how much? 273 Kelvin. Then we should calculate the delta TF, means a depression of freezing point we should calculate. After calculating this depression of freezing point, we should calculate that is the molecular mass of the solute, that is M2. We should calculate the M2. First we should calculate the delta, that is delta TF. That is delta TF. If we are going to be, we know the formula, delta TF is equal to, that is TF naught minus TF. Here TF naught how much they are given? 273 minus 272.07. We should be subtract by using the calculator. Then 273 minus 272.07 equals, we are going to be get that is 0.93 Kelvin. 0.93 Kelvin. Then we know the formula to calculate the M2, that we are going to be arranging, that is M2 is equal to, this is the formula we are going to calculate the molar mass of the solute. M2 is equal to Kf into W2 into 1000 divided by delta TF into then W1, mass of the solvent. Then the Kf how much they are given? The Kf is equal to 1.86 into W2 18 gram into 1000 divided by delta TF already we are calculated. We are going to be get that 0.93 into W1 is 200. Then we are going to be get that, we should calculate this by taking the calci, that is 1.86 into 18 into 1000 equals, we are going to be get that 33480, means 33,480 divided by, then we will calculate 0.93 into 200. We are going to be get that 186 186. Now we should do that. Divide this value 33480 divided by 186. It gives rise to 180. Means this is about the 180 is the value. We need to put the unit of that molecular mass. Unit of the molecular mass is gram per mole. Gram per mole. Unit also you compulsorily you should use, otherwise you are going to be lost 1 mark in this. That is, we are going to be get that M2 is equal to, that is molecular mass of the solute, we are going to be get that is 180 gram per mole. Gram per mole. ಇದನ್ನು ನೀವು ಕ್ಲಾಸ್ ವರ್ಕಲ್ಲಿ ನೋಟ್ ಮಾಡ್ಕೋಬೇಕಾಗುತ್ತೆ. ಇದನ್ನು ಕ್ಲಾಸ್ ವರ್ಕಲ್ಲಿ ಕೊಟ್ಟಿರಲ್ಲ. ಇದನ್ನು ನೀವು ವಿಡಿಯೋದಲ್ಲಿ ನೋಡ್ತಾನೆ ಅಥವಾ ಸ್ಕ್ರೀನ್ಶಾಟ್ ತೊಗೊಂಡು ಇದನ್ನು ಪ್ರಾಬ್ಲಮ್ಸ್ನ ನೀವೇನು ಮಾಡಬೇಕಾಗುತ್ತೆ, ಬರ್ಕೋಬೇಕಾಗುತ್ತೆ. ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಫಾರ್ ದ ಎಕ್ಸಾಮಿನೇಷನ್ ಪರ್ಪಸ್. ಯಾವಾಗಲೂ ಪ್ರಾಬ್ಲಮ್ಮೇ ಕೇಳೋದು ಎಕ್ಸಾಮಲ್ಲಿ ಸೊಲ್ಯೂಷನ್ಸಿಂದ, ಅದಕ್ಕೋಸ್ಕರ ಇದು ತುಂಬ ಇಂಪಾರ್ಟೆಂಟ್. ದೆನ್ ವಿಲ್ ಗೋ ಫಾರ್ ದ ಸೆಕೆಂಡ್ ಪ್ರಾಬ್ಲಮ್. Calculate the mass of compound. Molar mass they are given, that is 256 gram per mole, to be dissolved in 75 gram of benzene. To lower its freezing point by 0.48 Kelvin, then Kf is equal to 5.12 Kelvin kg per mole. What they are given, what we need to calculate, that we should be write down first. That is, if you are going to be taken this, that is delta Tf. We need to calculate the W2, that is calculate the mass of the compound, means W2 we need to calculate. In this, that is W2 we need to calculate. Then molar mass they are given, that is M2 is equal to 256 gram per mole they are given. Then W1 they are given, how much, 75 gram they are given. It lowers the freezing point by 0. Means delta Tf they are given, depression of freezing point is 0.48 Kelvin they are given. Then Kf they are given, that is 5.12 Kelvin kg per mole they are given. Then take the formula, that is the formula we are going to be used to calculate the W2 is, we know the formula, that is delta Tf is equal to Kf into W2 into 1000 divided by, that is M2 into W1. This is the formula. This we have to rearrange. We need to calculate the W2. That's why we are arranging this formula. W2 is equal to, that is delta Tf into M2 into W1 divided by, that is Kf into 1000. Kf into 1000. How much delta Tf? 0.48. Delta Tf is 0.48 into M2 molecular mass. How much they are given? Molar mass 256 gram per mole they are given. Then into W1, how much they are given? 75 gram they are given. 75 divided by Kf, how much they are given? That is 5.12 into 1000. We need to calculate. Take the calci. 0.48 into 256 into 75 equals, we are going to be get that is the value 9216 divided by, then you are going to be multiply, that is 5.12 into 1000. How much we are going to be get that is 5120. Then on dividing this, that is 9216 divided by 5120 equals, you are going to be get that 1.8 gram, that is the WO2. Then mass of the solute, this is about the mass of the solute, that is 1.8 gram. ಯಾವುದೇ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಬೇಕಾದ್ರೆ ಫಸ್ಟ್ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ಅದನ್ನು ಬರ್ಕೋಬೇಕಾಗತ್ತೆ, ಮತ್ತು ಏನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೋಬೇಕು ಅನ್ನೋದು ಗೊತ್ತಾಗಬೇಕಾಗುತ್ತೆ. ದೆನ್ ಓನ್ಲಿ ಇಟ್ ಈಸ್ ಈಸಿ, ದೆನ್ ಫಾರ್ಮುಲಾ ಯು ಶುಡ್ ನೋ. Then substituting the values in that, we are going to get the answer. This is about the molecular mass of the solute. We'll solve some other two problems. Just observe this problem. 1 gram of non-electrolyte solute when dissolved in 50 gram of benzene, 50 gram of the benzene, lowers the freezing point of the benzene 0.40 Kelvin. Find the molar mass of the solute. In this also we should calculate that M2. What they are given? WO2 they are given. WO2 is how much? 1 gram. WO2 is 1 gram. WO1 is 50 gram. Then the delta TF is, that is 0.40 Kelvin. Then we need to calculate, that is M2, that is the molar mass of the solute. They are given the KF, that is the constant, cryoscopic constant, 5.12 Kelvin kg per mole. Then we know the formula, that is delta TF is equal to KF into WO2 into 1000 divided by, that is M2 into WO1. We need to calculate the M2. That's why we need to arrange the formula, that is M2 is equal to KF into WO2 into 1000 divided by M2 into WO1. To rearrange the formula, that is delta TF into WO1. We need to substitute the values. How much KF? That is KF is equal to 5.12 into WO2 is 1 gram into 1000 divided by delta TF is equal to 0.40 into WO1 is equal to 50. Then we need to calculate this, that is 0.40 into 50 equals, we are going to be get that 20. Then 5.12 into 1 into 1000, we are going to get that 5120, that is 5120 divided by 20, we are going to get that 256 gram per mole. The M2 we are going to get that 256 gram per mole. Just observe previous problem and this problem. In that they are given the molecular mass, they ask the mass of the solute. In this they are given the mass of the solute, they ask the molecular mass of the solute. We'll see another problem. See the another problem. That is 15 gram of unknown molecular substance was dissolved in 450 gram of water. The resulting solution freezes at minus 0.34 degrees Celsius. What is the molar mass of the substance? What is the molar mass of the substance? This we are going to be taken that what they are given, WO2 they are given. WO2 how much? That is 15 gram. Then W1 is 450 gram. 450 gram. We need to calculate that Kf they are given, that is Kf is equal to 1.86 Kelvin kg per mole. Then delta Tf we need to calculate. Then Tf, how much? Tf is equal to, that is how much they are given, minus 0.34 degree Celsius plus 273. We need to convert into Kelvin. Then we are going to be get that. Otherwise we are going to be taken directly. It is 273. Directly you need to in degree Celsius only. If you need, you can take, that is freezes at the freezes at 0.34 degree Celsius. Directly you can take, no problem, nothing will happen. That is it. It's going to be delta Tf is equal to 0.34 degree Celsius. 34 degree Celsius. In this we are going to be taken as, that is formula delta. We need to calculate the M2 we need to calculate. Then M2 is equal to, that is W2 into 1000 Kf into 1000 divided by, that is delta Tf into W1. W2 how much they are given? 15 into 1.86 into 1000 divided by delta Tf is equal to 0.34 into W1 how much they are given, that is 450. We need to calculate this. We are going to be get that 0.34 into 450 equals 153. We are going to get that 153. Then 15 into 1.86 into 1000. We are going to be get that 27900. This divided by 153. We are going to be get that 182.35. That is 182.35 gram per mole. This is the unit for the molecular mass of the solute. Okay, next class we will discuss about the another colligative property, that is osmotic pressure.